introduced a bunch of new APIs that will help you build adaptive apps in a much faster and simpler way. Today, we're going to explore a bit more 3 of them. The latest 3 that we introduced this year at Google I/O as part of the Compose Foundation libraries. So, let's get started. The first API that I wanted to talk about is called MediaQuery. If any of you ever had any web development experience, this might sound familiar. MediaQuery is a small API that helps you understand what kind of UI capability are available on the device on which your app is running. It can give you a huge amount of data. And all this data, of course, will change every time that the capabilities of the device will change. But of course, we are not only talking about capabilities, like hardware capabilities, but also something that, as people that want to bring the app on every form factor, are basically the first thing we check, which are the software capabilities, like the Windows width, the window height, if the device has a folding feature and it's actually held in tabletop mode. All of this is provided by MediaQuery. But let's see the full list of everything that is provided. So the first one that I want to talk about is the window posture. Basically, we have 3 different window postures based on how the device is handled. The first one is flat. I mean, that's kind of easy. The second one is tabletop. That means that the device is held in this way. So you basically have it half open, and the hinge is horizontal to the plane on which the phone is staying. On the other hand, we have the book mode, which is half open, but the hinge is vertical. OK? Fairly easy. Then we have window width and window height. Those will return the DP size of the window that your app actually has at its disposal to draw itself. Then we have 2 interesting features, which is as microphone and as camera. Those return a Boolean, and hopefully they both return true if you need them. But of course, you don't need to check for every single capability. You just need to listen to those that you are interested in. Then we have pointer precision, where things get a bit more complicated, because it goes from the more precise to the least precise, basically the one that cannot really pointer. But anyway, this helps you understand what kind of pointing device your user is using at the moment. So it will give you the most precise one, so the one that is close to the equal sign, that it's connected. Whenever it's disconnected or another device which is more precise is connected, this value is going to change. Then we have the keyboard kind, which works exactly in the same way. Whenever you only have a virtual keyboard available, the virtual value is going to be returned. And whenever you connect a keyboard, you will get the physical keyboard kind. Last but not least, the viewing distance, because not everything is always held at close quarter. You might have something which is further away, like a car dashboard, or something which is even further away, which is a TV, for instance. But how do we use this API? Perhaps you all know, but I love to repeat myself. So let's see how we can use them. First, we have to define one additional bit of information. That is that we have frequent and non-frequent updates. Basically, the frequent updated values are 2, which are window width and window height, because you can definitely drag the window and start resizing. In this case, you will not invoke the MediaQuery directly, but you will use the derived MediaQuery. No worry, you don't need to remember that. The compiler will tell you. It will tell you, no, you cannot do that. That's too frequent. No. So basically, this will debounce so that you don't cause too many recompositions. Instead, for everything else, you can use the normal MediaQuery call and that will work normally. So now we can try these APIs. OK, so first of all, let's see how the sample looks like now. So we are talking about adaptive apps. So I expect that my app is actually broken badly. And yeah, yep, looks like it's broken badly. OK. So we need, first thing, to understand what kind of space we have. Because we just saw MediaQuery, and for our very simple sample, we want to know only how much space we have to draw our UI. What we did here is actually calling the derived MediaQuery, passing what we are looking for, and what is our constraint. Because it's much faster for us to just get, oh, is this matching? Yep, perfect. But let's see what happens if I actually want to use the MediaQuery. You see here, the compiler is already telling me, please stop, should not do that. So don't worry. OK. OK, now, since a truly adaptive app cannot really work with just one breakpoint, and for the past years, we all have experienced that there are different breakpoints, like at least 3, that represent more or less closely a handheld phone, an unfolded foldable, and a tablet, we want a second check to make sure that we actually are checking correctly and all our architecture, well, works. So now that you know what we are looking for, we should use derived MediaQuery or MediaQuery. Who thinks we should use derived this time? OK, yes, the few that raise their hands actually think that we are using derived. You're right. My goal here is to make sure that you understand exactly why you should use derived. So just to recap one more time, window width and window height are frequent updates. They will cause multiple recompositions if you don't use derived MediaQuery. So let's see how that looks like. And OK, here, what we did here is exactly the same thing. This will return true whenever this condition is matched, and this will return true when this condition is matched. Of course, one thing to keep in mind when dealing with breakpoints, Windows size class, and media queries is that they always have to be checked in order. Because if you check this one first, well, that doesn't really work, because you will never reach this one, because this will always match when this is true. So you want to test this, because this will only pass when 840 is available. This will only pass before. So you want to check for the largest first, and then you go to the smallest. That's something that you need to remember. Otherwise, you will incur in funny bugs, and you will see your UI behaving in a way that you didn't expect. So let's go back to the slides, and we can talk about another API that we introduced. OK, the next API that I want to talk about is FlexBox. So again, this API has been heavily inspired from the web counterpart. FlexBox is a container that lays out children in a single direction. That means that it can go vertically or horizontally. So it can place items in a row or in a column. And it can also use the reverse of them, so a reverse column and a reverse row. So that means that if you ask it to place items from the start on a reverse row, it will actually go to the end, because that's the reverse. It can, of course, resize. Wrap means go on another line or column, align, and distribute space across the children. And it will try to fill the space optimally. OK, so to give a very quick example of how FlexBox work, we can use one line of code, well, three, but let's say one line of code, which is the direction. The direction is what tells the FlexBox how you want it to lay out the items. This is very important, because this is the main direction that your UI is taking. So I want you to focus on the order on which we declare the items. You see, the first one is the red rounded box, which appears here at the bottom. Okay? That's because we declare the direction as being column reverse. So it will start from the bottom. But that gives us a very precise hint of the inner working of FlexBox. To achieve this feature, it cannot support lazy loading, because it needs to know exactly how much space each child is going to take before laying them out. OK? So this is very important. So we understood that FlexBox doesn't support lazily loading items. OK? Now, we mentioned that it can fill the space in the optimal manner. What we have here is that FlexBox can ask one of its children to take up all the available space by using the grow modifier inside Flex. So the Flex modifier is scoped to the FlexBox, so it can only be invoked inside a FlexBox. So if you want to abstract data away, you need to pass the Flex modifier from outside of your composable. OK? What happens here is that FlexBox will calculate how much space it has. It will calculate how much space the two children, the red and the green, will take up. And then it will increase the amount of space that it's at disposal of the blue, because it's the only one that has a Flex modifier that indicates that it can grow up to the full amount of space available. So grow will take a float that goes from 0 to 1. So grow nothing, or grow to fill all the available space, and everything in between. As you can see in the example, based on how much space the container has, so 600 EPs, 840, or 1200, the blue will grow accordingly. And of course, the same is also available for shrinking. And it works in the reverse way. But what happens when there is not enough space? You have two solutions here. You either ask the FlexBox not to wrap, so everything will be basically compressed, or it will just wrap and try to fill the space in an optimal way. So you see here we added all the flex grow, so that we say, OK, whenever you wrap, just let them grow until you have space. So how does that work under the hood? Basically, it will take the first element. It has a size. I say, OK, that's your size. It will go to the second element. It will check, does it have enough space to render here? Yes, perfect. It will go to the third element. Do you have enough space to render on this specific line? No. OK, let's wrap, and let's recalculate how much space the other two has, and so on. So that's why you see it appearing in this way, because it does all the calculations to make sure that your layout always fills all the available space in an optimized way. Now, let's see how the FlexBox works in practice. So the first thing that we want to do when we create a FlexBox is actually creating the configuration. So what we need to do here, again, FlexBox is a composable that contains other composables. So the first thing is that we invoke the FlexBox, and we add a configuration. Most of the values inside the configuration have sensible defaults. So most of the times, you don't need to change everything. But what we want to do in this sample now is that it's actually something slightly more complicated than the normal use case. What I want to achieve is a FlexBox that will have one button on the start that is of a fixed size, and a button that will take up all the available space. But that only when we have enough space. When we don't have enough space. When we have enough space, only one button will be shown, and it will have a fixed size. So the first thing is that we need to declare the configuration. OK, let's try to understand what we do here. So the justify content will distribute your items along the main axis. That means that if we chose the direction which is horizontal, it will justify the items on the horizontal axis, while the align items acts on the cross axis. So in this case, vertical. As I mentioned earlier, I didn't define a direction because the default is row. If we wanted them to be a reverse row, I would have to actually define it. And then we added the gap. That basically says, OK, place the items, but I need some breathing between them. What happens here? Basically, we check. If we have enough space, we checked that with MediaQuery earlier, it will just center my content. So everything will be placed in the center of our line. Otherwise, it will add a space between them that is added to the gap. So the gap is always present. But in this case, whenever we don't have enough space, it will add some spacing between the children. Now, we just need to add the content and here we are. Again, what this FlexBox does at this point is checking, do I have a smaller amount of space? If the response is yes, I don't actually have that much space, then it will draw the settings button. Then it's time for a play pause button. So if it doesn't have enough space, it will take up the whole space thanks to the flex and grow modifier. Otherwise, it will have a fixed width. How does it work in this way? So we told earlier that the MediaQuery will return a different value whenever the threshold changes. So whenever these changes, it will recompose the whole thing and calculate how much space it has. And it will do that in an optimized way. Again, we can do all these tricks because we know exactly how much space they're going to use, so our FlexBox doesn't really suffer that much. And let's see how it looks like. So as you see here, we don't have enough space. So we show the button when we press here. Now we have enough space. The settings button disappeared because we have the panel. What we did here, so basically we applied one of the core principles of adaptive apps. We changed how our app looks like based on the capability of the device. So we only use 2 of these APIs, and already our app looks much better than it was looking before. This paradigm that we used, which has 2 panes, one aside of the other, and they display together whenever there is enough space, and only one displays when we don't have enough space, it's called list detail, or actually, in this case, supporting pane. They are very similar in the sense that you can show 2 panes side by side when you have more space, or only one when you don't. But what changes is the relationships between the main content and the secondary content. In this way, the settings are more of a support for the main content. If we add a list, and each list would open a detailed view, that would have a more, let's say, equal importance, and the relationship will be slightly different. But for us, in this scenario, we can use one or the other. Now, time for the last API of the day. Can we go back to the slides, please? So we saw MediaQuery. We saw FlexBox, which is a layout that lays items down in one direction. And now we can talk about grid. As the name might imply, it actually creates a grid of rows and columns. OK? But how does it do that? I mean, why is it different from the lazy vertical grid, or the lazy horizontal grid, or the lazy staggered grid? Well, first of all, they are all lazy, and the grid is not. The grid makes an amazing component for anything that doesn't need to be lazy. OK? Anything that needs to be laid out completely at the same time. So, for instance, a route layout. OK? But let's see how actually is composed, this grid. First, it has 2 dimensions, rows and columns. And you can define how much space each track, rows, and column can have. It can be fixed, it can be a percentage, or it can be flexibly defined. And of course, you can decide that each item spans across multiple cells. OK, so to give you an easier to grasp image, mental image, imagine a newspaper. A newspaper has a very specific structure. So you have the header on top that span across the whole site. You have the footer at the bottom that's the same. And then you have the 2 shoulders that span for probably 1 column, but for all the length of the page. And then you have the central content, which is a grid of little articles that change the size based on editorial choices. You can do that with a grid by simply calculating how much columns and rows you would have, and then asking each item to span on the column and rows that you need. So how do we create such layout? First, in a very similar way to FlexBox, Grid accepts a configuration. The configuration here defines 2 columns and 3 rows. You have to define at least 1 and 1, otherwise it doesn't really know where to add the items. And that's basically the basic configuration. Automatically, it will place the items with the sensible defaults. So as you see here, the sensible default that has been chosen for grid is a column first and then rows. So you see, we define the red, which happens is positioned in the first cell. Then we have the grid in the second cell of the first row. Then we go to the blue, to the pink, to the orange, and to the yellow, without the need of defining anything. One important bit about the grid is that it's 1 indexed. So the first cell is actually 1, 1. It's not 0, 0. But it can also work with negative numbers. So if you add -1 and -1, it will target the last item. OK? Pretty fancy, right? We mentioned earlier that we can define the track in different ways. The first one is easy. I want the column to be 150 dps. That's easy. 150 dps, that's it, done. The second one starts to be a bit more complicated, because here we deal with percentage. And we ask it to take up 50% of the space. But in this case, when you invoke the column or the row with the percentage, you are asking 50% of all the space. OK? But you can also ask about the remaining space. And you do that with the .fr extension function. To explain in a bit more detail how the .fr work, let's do this little exercise together. So let's try to divide a row in 4 columns of equal size, only using the fr. So we start from the first. We want 1/4 of all the available space. OK? Let's divide it in 3, because it's late. Less math for everyone. OK, so we want to take up 1/3 of all the available space. So we say .3.fr. Now, we want the second column to take another third of the available space. But since here we are dealing with the remaining space, we need to be a bit more creative. Because if we think about it, we now have 2/3 of the space available. And since we want 1/3 of that, that means that we need to ask for half of the remaining space. Then at that point, we want the last third. And that to be the all available space. So we will need to ask for 1.fr. So the .fr extension function is incredibly powerful. But it's also tricky, because you need to remember how to invoke it in the right way using the calculation that you want to get exactly the result. Or you could use the percentage and deal with that. That's your choice. But that's important that you remember what is the difference between the two. Percentage will take up all the available space, so before the computation. fr will take the available space. That means after the items before it are calculated. One is before, the other one is after. Now, we mentioned that that items can span across multiple cells. How we do that? Well, we have a grid item modifier that is scoped to the grid composable. So you can only use it inside a grid invocation. The grid item has sensible defaults, and you can override only what you need. In this case, we see the red box that takes up 3 columns, and the column span 3. We have the green box that takes up 2 rows and 2 columns, and we have the blue box that takes up 2 rows. As you saw here, we didn't specify any position, because it knows that it needs to go like this, like this, and like this. And when it fills the first line, it will go to the second. In this case, it takes 2 rows, so it knows that it only has this tiny place to put the blue one. But also, we added something that makes your life much easier. In the latest beta, we introduced the named areas. Those, in a totally different way from what we saw now, are to be declared inside the configuration. And basically, they will name a specific amount of cells inside your grid. So in this way, we can really think about that newspaper layout that we were talking about. So we say here, my first area is actually a header. So I want it on the first row, first column, and I want it to span for 2 columns. Then we have the sidebar. That's fine. Place it wherever you want. Well, no. I need 1 row. Same thing we do for the green. And for the footer, we actually define the range of rows and columns. So when we now go and ask for our items to be placed, we simply say, OK, you know what? Just place it in that area. Why is this important? Because now we only saw the layout happening in one scenario. We didn't care about anything else. But in a real-life scenario, you would have conditions in your configuration. And it's much easier to have your named areas all tighten up with the configuration so that whenever the configuration changes, the rest of the children just adapt without the need for you to override all the grid items parameters. Now, let's see the last example of the day. So the first thing that we want to do in this case, because I just wanted to add the grid to our sample, we need to declare how many cells we want. Because we noticed earlier that we need to tell it how many rows and columns we actually need. And we give each of these cells a weight in percentage. Then we invoke our grid. In the same way in which we declare the FlexBox, our grid expects a lambda, which is the configuration. So let's add the configuration. And what we did here is simply adding as many columns as we need and as many rows as we need, giving them the same amount of space. So if we add 2,000 rows, they will have the same space. If we have 3 rows, they will have the same space. So all of this is useful because in the sample, you can slide the number of cells, and it will just change dynamically. Now, let's add the children. OK, and what we did here is simply add a new composable, which is a cell for every of the cells that we have available. So it's actually fairly easy to declare a grid. The part that will change most of the cases is the configuration. So whenever you want to use the grid and make it adaptive, this is where you're going to act. Together with MediaQuery and FlexBox, they will make your life much, much, much easier when developing adaptive apps. And for a final check of how our app looks like, here we have all our components here available. And as you can see here, our grid adapts quite easily. And our code was really 2 lines of code. MediaQuery works. We saw that earlier. And FlexBox works. All in 40 minutes. Yay! Thank you so much. Now, if we can go back to the slides, please. All of these can be achieved by hand, but you can also use the skill that we demoed today at the keynote. So if you go to this address, you can download the skill and try it out by yourself. Now, if there are 3 things that I really would love to transmit after this talk, is that we have 3 super nice new APIs, that adaptive is a journey, is not a one-shot. It might take time, and it might take effort. It's a journey. But we have tools that can help you, and the quality tiers guideline will guide you in making your app adaptive in the easiest possible way. And thank you all so much for attending my workshop and all the other sessions. Thank you.